When you think about the chips powering today's AI systems, what probably comes to mind are GPUs. But these were designed to render graphics like in video games. And if you were to start from scratch and design a chip for today's AI systems, you might come up with something quite different, especially as the key focus moves beyond just training models and starts really using these models to draw conclusions and make predictions. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in two U.S. cities.
As the disk rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte I present to you Electro, the Moto Man. Ladies and gentlemen.
I would say that one of my greatest skills is my ability to interact with humans.
This episode, it's the latest installment of our oral history project.
Hi, Sam Ransbotham here. In each episode of Me, Myself, and AI, my co-host Shervin Kodabanda and I talk with leaders from organizations like Shopify, NASA, GitHub, and Amnesty International. We explore how organizations achieve success with generative AI and what challenges and ethical considerations they face along the way. Whether you're leading a strategic technology function, deploying ML solutions, or simply curious about what's behind the hype, Me, Myself, and AI delivers actionable insights for value with artificial intelligence, while sharing the backstories of people who make this technology work. Listen to Me, Myself, and AI wherever you stream podcasts.
This episode is brought to you by Tools and Weapons, the podcast exploring technology's impact on our changing world, hosted by Microsoft's Vice Chair and President Brad Smith. Across 3 exclusive conversations celebrating the company's 50th anniversary, Microsoft's CEOs Bill Gates, Steve Ballmer, and Satya Nadella share the untold stories, big dreams, and relentless drive that's fueled a digital revolution. Hear why each of them thinks that the revolution may be at its most exciting point yet. Find the CEO series and other impactful conversations with government, business, and cultural leaders by searching for Tools and Weapons wherever you listen to podcasts.
Remember the old story about the bear chasing the men, right? You don't need to be faster than the bear, you need to be faster than your friend. And it was clear that significant improvements could be made if we started with a clean sheet of paper and designed a new type of processor specifically for AI work. My name is Andrew Feldman. I'm one of the founders, and I'm CEO at Cerebras Systems. Cerebras builds a new type of computer optimized for AI work. And what that means is we do both training, the making of AI, and the inference, which is the using of AI. And we build both of those. Cerebras was founded in 2016 by 5 of us, J.P. Fricker and Michael James, Gary Lauterbach and Sean Lee, and myself. We had all worked together at C-Micro and was acquired by AMD in 2012. We worked at AMD for several years, and then we wandered our various ways. Took some time off, studied tango dancing. People did woodwork. But by sort of Q3 of 2015, we'd gotten together and we began meeting, and we wrote 2 things on the whiteboard. We wrote that we wanted to work together again and that we wanted to move an industry that we cared about. We didn't want to build something incremental. We didn't want to build something for money. What we wanted to do was make a lasting impact on an industry we cared about, which is the compute industry. And we began looking at different ideas. And when a computer architect looks at ideas, they look at the world as, can I build a new type of computer that's good for blank? And one day, Gary leaned back and he said, why would a graphics processing unit that for 20 years had been tuned for graphics, why would that be good at AI? And wouldn't it be serendipitous? And he used the word serendipitous, which nobody uses, right? Wouldn't that be serendipitous if 20 years of tuning and improvements for one type of work left you well positioned for another type of work? And what that did is it opened up a problem space for us. We said, wow, that would be weird. And let us look at what artificial intelligence software asks of the underlying hardware. What's hard about it? And let's look at the architecture of the GPU and see if it's well designed for that problem. And what we found, of course, was that the graphics processing unit was a perfect machine for graphics processing. Not a surprise there, but it was less bad than a CPU. And those were the only two options over there. As we turned that idea over in our head, we realized something very unusual about AI work. There are two things a computer does. It does calculations and it moves data. And AI has an unusual combination in that it does a huge amount of very simple calculations, almost trivial, but an unbelievable number of them. But it has a very challenging problem in moving data to memory and from memory, and breaking up problems and moving intermediate results around tens, hundreds, thousands of cores. We thought to ourselves, if we could make innovations on the dimension of communication, on the movement of data, we would be able to accelerate this workload and do so at a tiny fraction of the power draw. And so we set ourselves the task of building the largest chip in the history of the computer industry. And by building a big chip, we keep more data on chip. We have to move it less. We keep it in this extremely high performance domain of on silicon where it uses very little power to be moved. And in August of 2019, we announced that we had solved this problem that in the 70-year history of the computer industry had never been solved. We built a chip the size of a wafer. So most chips are the size of a postage stamp, and we built a chip the size of a dinner plate. And that this chip sort of violated many of the rules that everybody had been taught obtained. We could yield it, we could manufacture it, we could deliver it, and it was blisteringly fast. It was faster at training, it was faster at inference. At 16 nanometer, that was our first generation. We're now on our third generation. We have thousands of systems deployed. We are today order 70 times faster than a GPU in doing inference. We power the likes of Perplexity, the very cool AI search engine, Mistral, the super cool French foundation model builder. We power AlphaSense, and a whole collection of others on the inference side. On the training side, we train foundation models for large enterprises like Mayo Clinic or GlaxoSmithKline or Total Energies, and cool work is being done with our machines every day.
A cluttered desktop isn't just an eyesore, it wastes mental energy, slows down your Mac, and hampers focus. With Clean My Mac, you'll boost both your Mac's performance and your productivity by easily identifying and removing large, unnecessary files, including cache files. Clean My Mac finds outdated files that can be safely removed, so there's no need to worry about losing important documents or photos. Decluttering isn't just about speed, it's about creating an environment that helps you work smarter, not harder. I make a real mess of my machine with all the audio files that go into making this podcast and others, and the Smart Care feature ensures my Mac stays in top shape. With one click, you can free up RAM, manage processes, and even check for malware. So deep clean your Mac, scan for potential threats, and boost performance all with one click. Experience Clean My Mac for yourself. Try it free for 7 days and use promo code SHIFT to save an additional 20% on your purchase at cleanmymac.com. That's cleanmymac.com, promo code SHIFT.
The world's hardest problems can't wait. Food security, energy resilience, the digital divide. I'm Astro Teller. For 15 years, I've worked with inventors and engineers to tackle the seemingly impossible. In the Moonshot podcast, we take you inside X, Google's Moonshot Factory, giving you unprecedented access to the messy, exhilarating journey of turning science fiction into reality. This is the Moonshot Podcast, out now wherever you listen.
The way you make AI is something called training. And this is how AIs are made. And the way you use AI is called inference. And so when you type into ChatGPT, help write me a paper for an 11th grade social studies class on the Vietnam War, that's an inference request, and it produces an output. And that's how the AI, that's ChatGPT, is used. There's a fundamental architectural challenge with the GPU for inference, and that's that the memory is off-chip. And inference in generative AI, the weights have to move from memory to compute to generate every single word. To do that, you have to go back and forth to memory an unbelievably large number of times. And if your memory is not very close to compute, like on the same chip, your compute spends a lot of time waiting, and the result is that for inference, GPUs generally run at about 5 or 7% utilization. That means they're 95% wasted or 93% wasted. On the other hand, our architecture put the memory right next to compute on the same chip. We were therefore faster, no waiting, and we used less power because we were doing more work instead of waiting while we were drawing power. Sometime in the end of Q3 24, beginning of Q4, AI became useful, right? It stopped being a novelty. And when people use AI, they're doing inference, they're the same thing, and the usage went through the roof. And we know exactly how much compute is going to be used with a simple equation, right? Number of people who use AI times the number of times a day they use the AI times the amount of compute each request takes. And each of those dimensions is increasing exponentially. And as a result, the AI market for inference is ripping right now, absolutely ripping. We are in this sort of first blush of AI usefulness, where maybe 8 or 10 months ago, you would occasionally use an AI if you were in marketing, and now you ought to be going to one form or another of an AI 6 or 8 times a day like you go to Google. I think this is happening across fields. I think the AIs themselves are getting better. Each generation is allowing us to do more. I think we can see them being more useful than giving us answers. We can see them actually doing things for us. Right? We like to complicate it and call it agentic and make up words that make it feel like our technology is more complicated. That just means the AI does stuff for you, like make me a website. There's a bunch of little stuff you do, reorder my prescription, do research on a patent portfolio. We're on the cusp of that right now. AI is becoming useful. We are making fundamental improvements month over month. You know, what was considered a good AI 6 months ago is now long in the tooth. And I think for those of us who've been in the industry a little while, we've never seen an industry move this quickly. I mean, there's something absolutely magical happening in that there is a race, and there are dozens of companies in it. There are nations in it. There are hundreds of billions of dollars being put to work, maybe trillions of dollars being put to work in it. And people are working unbelievably hard, and progress is happening so quickly, it boggles the mind. I think when you think of how you make a computer, you think there are 3 components, and there are only 3. There's the calculation, and we call that compute. There's the storage, and there's the communication. These are the 3 things we play with. Storage is either memory, or it's how we store a result over time, how we move it over time. And the communication, the I/O, is how we move information over space. And the calculation is what the transistors do. We have gotten very, very good at the calculation. We have made far, far less progress on the I/O, on the communication. We move it more slowly. The improvements that sort of we got from Moore's Law and that we continue to get in various techniques, such as going to wafer scale and others, have not applied to memory. And so we can make a lot of compute on chip, but it is harder and harder to store it or move it. And I think you will see in the months and years ahead tremendous innovation and efforts to innovate on those dimensions. There's tremendous opportunity. They've been sort of out of favor in the VC community for a generation. But I think those are the limiting factors of compute right now. The other element that is a feeder to all three of those is the delivery of power. And most of us who build high-performance computing devices would like to get more power into our device. And the power regulator and the various things that deliver power to us are also a major constraint in the compute world. And so I think if I were to make a prediction, I think you will see tremendous innovation in the delivery of power. I think you'll see tremendous innovation in memories. We have a very long way to go to be able to move data as fast as we can calculate results. And those are some of the things that I think are heading around the corner.
This episode was produced by me and Emma Cillekens and mixed by Garret Lang, with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong.